Hello everybody. Hope you guys are doing well. So continuing on our journey, today we would be trying to understand NumPy basics. Before we do that, uh, what we can do is let's open VS Code. Yeah, let's close this thing. Let's get Visual Studio. Then let's open uh there was yeah, it should be here. No, you can mm, yeah, it should be somewhere here. Uh, oh, there is no folder called, yeah. Let's open this. Let's have our terminal. Uh, uh, let's open our. Let's have our virtual environment running. I forgot the command though. It was work something. Uh, or there should be a. There should be this file. Okay, let's bring up our terminal. So terminal is here. Let's move it, and then let's. So ours alias was work on Jupyter, right? So let's have this command. So we do work on work on is on one, and then you have hyphen Jupyter. Yeah, so the virtual environment is launched. Uh, let's get rid of matplotlib right now. Let's get rid of this as well. V. Oh, I have to change it to, yeah, it should be this. It's yeah. So right now our virtual environment is started. Let's go back. Let's go to OBS. Let's set this. Okay, so yeah, so now we are basically dealing with NumPy. It's okay. The NumPy. So NumPy basically stands for numerical Python, one of the most important foundational packages for numerical computing. Most computational languages providing scientific NumPy. Okay, so now we are talking about. Let's so basically this is for Numerical computing, numerical Python. Now first is features of NumPy, right? Like why do we have NumPy? First is basically we would be able to create a ND array, right? So it helps that ND array creation. ND an efficient multi-dimensional array providing fast array oriented, so like array oriented operations, right? For example, it could be array like array multiplication, addition, subtraction, arithmetic with array. So remember, array multiplication is going to do for multiplication to happen. If this is an m cross n, and this is a, so these first criteria is these both have to match, right? And then every uh, column of this gets multiplied with every element of the row, right? So it is going to take some time. So NumPy makes this a bit faster. This is especially useful when you're doing something called as convolution, right? When you're dealing with images. The tools for reading and writing array data to disk and working with memory mapped files. Again, all array related operations. Uh, the second is again reading and writing array. So yeah, reading, writing. Next thing that you have is linear algebra. We'll see what linear algebra is. Then random number generation. Again, now a C API for connecting NumPy with libraries written in C or C++ or Fortran. Because NumPy provides an easy access to C API, it's straightforward to pass data to external library, the lower level language, and also for external. Remember, so if you see Python, right? Python last stage is basically something called as C Python, right? So this is basically more faster. Now, okay. While NumPy does not provide modeling or scientific functionality, having a NumPy, uh, because so why we need to store or why we need to create this NumPy arrays is for further use, right? So later on we would be dealing with something called as uh, pandas, right? So for to work in pandas, we need data to be stored in form of an array, right? When more complex way, you can say we need data to be stored in NumPy arrays, right? Now, see, it's straightforward to pass data to external libraries. Now, while NumPy itself does not provide modeling or scientific functionality, having an understanding of NumPy arrays and array-oriented computing will help you use tools with array-oriented semantics like pandas. So what he's saying is, for prerequisite to work in pandas, right, we need data to be in an ND array. That ND array is provided by NumPy. Now, for more data analysis application, main areas are vectorized array application, okay, array algorithm sorting, setting, descriptive statistics. We'll see that all. Now, array oriented computing, yeah, this is now one of the reasons NumPy is more important is because of the efficiency on large arrays of data. Again, you can create a very big array, big data, right? So the same thing. So there is a difference between ND. Okay, now some might people might be thinking that we do have list and tuples, right? So we have a tuple. So if this is my tuple or a list, right? Now the uh, first thing is the now both list and tuple do not have editing, right? By what I mean by editing is you cannot add new members or and then if I have a if I have multiple, so again we can have a tuple as well, right? So if you do multiplication in tuple, if you store data and multiply in tuple, the same thing that you do in when you're doing by creating an ND array, right? The time taken is the difference. So we can check that thing. So there is a, you can measure the time taken. So let's go back to yes. Let's get rid of this. Let's have NumPy imported. So I'm just going to create a random array. Let's say this is my array, and then I'm going to np dot. So I'm going to do a random number generation. Or let's create it from a range itself. So a range, uh, start, stop, step. Okay, so what I'm going to do is I'm going to now this is specifically NumPy related thing, right? So I pass in 1000 and I do and the same thing I do my list and I do a list generation. So you do list and then you put in a say 1000, right? Same values. But let's make it 10,000. Let's have a bigger thing. The time thing will be more clear when we do now. And then so now okay, so let's have them printed here. So let's say print my array, and then let's say I have print my list, both of them. Okay, so this is the first is basically from 0 to 999, right? This is my reach. The next thing that I'm going to do is basically now let's calculate the time. So I'm going to do percent time, and then so this, so let's check how much time did it actually take to. What we are going to do is we are going to multiply each element. So in my array, oh no, let's say let's we say we have this way. Let's do 20 multiplications only. And what I'm going to do here is let me check. Yeah, this is a very basic thing that's done, right? So I'm trying to check how much time it is going to take. Oh, so this is like a magic command. What I can do is let's have a new cell probably. Yeah. So let's have say this is and then let's say this is, and then let's multiply it by 2, right? So my array, okay, first is, yeah, let's say now we are trying to perform some mathematical operation, and let's say let's run this. So now how much time did it take? It took 3 microseconds, right? Okay, let's have another snippet. Now in the other thing what we are going to do is we are going to use the conventional method, right? So when I do that, this is going to be for, again, same thing. So here, okay, now let's create a new list. So I'm going to do my list too. So now here I'm using this list comprehension. So I do x into 2, and then for each element in my list, right? So my list, yeah, let's see. This took 4 okay, so this is usage as a nanoseconds, right? So basically runtime, so if you see the difference here, they will be 10 to 100 times faster or more than their pure Python counterparts. This is like because of that C Python live thing, right? That is what is making it more faster in terms of, yeah. So this is taking, you see, this is, see, if you see, it only took like see the difference here, it's like 100 to 10 to 100 times more faster, right? Now why it is faster is, um the reason for that being is, that C Python thing, right? Let's see why NumPy is faster. And NumPy does something called as vectorization, right? uh, okay, so now why NumPy is faster? Let's let's have, so why NumPy is faster? Now it does something called as vectorized multiplication, right? We do vectorized. We'll see what this vectorization process is. And under the hood, C is written, right? So making it more closer to the libraries. Then it uses something called a single instruction multiple data level, and so it has two libraries as well. It uses two libraries, SIMD, and we'll see everything when we create, right? Now this is basically for single instruction multiple data level. So this is the full form is, or this stands for single instruction. And then BLS, this stands for um, basic linear algebra subprograms, right? Basically it has optimized mathematical programming. So basically this is uh, basic linear algebra subprograms. So this has something called as optimized maths. You can say optimized maths. Okay. The fourth point that we have is basically it has something called as uh, better memory layout. So it has, or this is also called as contiguous memory. Contiguous memory blocks. We'll see how this affects the storage, right? So the benchmark that is said that has been said is, so normal Python. So if you use a list or a tuple to perform the same thing, it will take um, it will be when compared to when compared to list and tuple. Okay. Uh, where is my, yeah. When compared to list and tuple, so NumPy will be 5 to 10 times faster. So you'll be having 5 to 100 times faster, right? So hence, whenever you're doing this multiplication or any other operation, it's preferred to use or especially when you're working with arrays, right? It's preferred to have multiple. It's preferred to use NumPy. Now NumPy ND array. One of the key features is ND array or ND array, which is a faster, flexible container for large data sets. Array is unable to perform mathematical operation on home blocks or data. To give you a flavor of so one more feature is it kind of does something called as batch processing, right? We'll see all of them and why batch computations or batch. Yeah. Okay. To, to make it more technical, let's say it does something called as batch computation. Now, okay, so and what it does is any let's just try to see. Uh, so by batch, let's try to understand what I am at, what we means. What do we mean to say when we say by batch processing? Oh no, oh wait, I got the cell on the wrong location. So yeah. So first is basically again we need to import, right? Although it's already imported, it might not be needed now, but okay. Oh, the NumPy is it's in the same file, right? So not needed. Now let's create a data is let's do a random, and then now we need to generate an ND array, right? So there is a function called as rand. Okay, so now this is a convenience function for using. Now it if positives arguments are permanent, then it generates a shape of 0 d01 filled with random float samples from a we'll see what this univariate bivariate is. This is more towards stats, right? So yeah, we'll see that thing. This is a convenience one. Okay. So it takes parameters. Int dimension of the returned array must be non-negative if the no argument is provided and a single slot is returned. Okay, let's just run this. Now let's create so we created an ND array, right? Oh, let's print it. Okay, let's get the thing out. So this is the ND array that we generated. Let's create another markdown, another cell, and let's try to multiply. So at a time when we do data into 10 and then we print data, so this is some cool thing. So if it was a list or something, then we'd have to iterate it. Or did it get multiplied? Uh, or let's just say the thing is that's not getting changed, right? We print. So we multiplied all of these by 10, right? So it did in a single flow, right? There is no loop or something that is running. Even if you are trying to add, now especially when you are doing multiplication is the issue, right? Let's say let's add in wait, let's say oh yeah, and now let's just add over here. So we added these two elements, right? The first in first what we did is all elements have been multiplied by 10. Now in the second, corresponding values have been added to each other. An ND array so basically here we have done operations to whole blocks, right? Okay, let's see how. So if I was to do in math, how does a matrix multiplication take place? Let's see some example that would make it more clear. Hello. Yeah, so let's say we are trying to learn how matrix multiplication happens, right? So if you have two matrices over here, and so an ND array can be considered as a matrix, right? So for example, I have a matrix over here. This is a very basic. So this is like, so you have, these are the elements, right? So suppose this is a matrix A. This is, and then this is matrix B. So this is a 3 cross 2 matrix, right? So you have, okay, so here, so the dimension of basically indicates m cross n, right? Basically this is number of rows and this is number of columns, right? So each matrix has that. So for matrix multiplication to occur, there is a rule, right? So if so this is uh, so this is a 2 cross 3 matrix and this is a 3 cross 2, right? So the rule of matrix multiplication is the number of rows of first matrix should and the number of columns of the second matrix should match. Then only you can perform matrix multiplication, right? So the way the resultant is going to be calculated is, the way we calculate the result is uh, okay, so the way we are going to do is, the resultant matrix will be a 2 cross 3, right? Will be a 2 cross 2. That is what the resultant, so it is going to have 2 rows and 2 columns. So 2 cross 2 matrix. Okay, so the way the multiplication is going to happen is, oh, okay, yeah. So what is going to happen is over here is, so this I want to multiply first with this. So the rows, each row is going to get multiplied by the column. This is going to happen the first time and second time. Similarly, second row, first column, and then second row, second column. So the resultant is going to look like this. So it's going to be, so the resultant, this is C, right? So my C resultant is going to be 1 into 7 plus, and then this is going to be 4 into 7. So this is how the resultant is going to be calculated, right? So this is going to be, say this is going to be 5864, and then this is 139 and 154, right? So this is how the matrix multiplication is going to happen. Now if I want to write a code for the same thing, I'll have to loop. So a pseudo code would be like, uh, if I'm not if I'm doing a pseudo code, so it will be taking having a loop running, right? So I will be having a loop that is going to run through this column and multiply with each elements of this, right? So it is going to be some sort of n square, I feel, n square complexity maybe. So so we know the resultant how it's going to be, right? Yeah, it is going to be some sort of n square complexity. Now this is so basically we are taking each element and multiplying it, each element in row in the column of the second multiplied by the uh, each element in the row, right? So since we are doing each element, this is more like this is like passing through the uh, each single array one at a time, right? So the complexity at the end is going to be this might result in a O of n squares type of complexity, right? Because two loops will be running simultaneously. Now how does this, from how do we go from O of n square? Like O of n square is not a very good complexity, right? It's a very bad time taking operation, because if you just take the input size will be like 10 power 8. So 10 power 8, what if this input size is like, say I have an input that is equal to 10 power 8. So the resultant that I will be doing, like the time that I would be taking is going to be uh, 10 power 16, right? So this is not a very good way, or not a very good method. So how does NumPy? Now, NumPy does something called as vectorized operation. Let's see what vectorized operations are. Now we are going to do vectorizing the operations, right? Okay, so now what we are going to do is we are going to do something called as vectorization. So how does vectorization work? So like what does vectorization work under the hood? First, let's have a formal definition of vectorization. So vectorization, the definition itself is, the vectorization means instead of uh, what do you say, instead of operating on the whole array, we instead of operating at each individual element in the array, you operate at a whole level. So what you do, operate on the array as a whole, instead of operating on single elements. So this is the core reason behind vectorization, right? So hence when we pass in an array in NumPy and we multiply it by 2, right, does not work on a uh, uh, on individual elements. It takes that whole array as one single unit of work. So hence now under the hood, what does it loses? It uses it does something called as uh, parallelism. Like it it works. It uses something called as parallel programming, right? Or something called as concurrency. So let's try to understand a little bit more about. Let's dive a little bit deeper about it. So what we are doing is, so suppose we are multiplying the elements of an array by 2, right? Suppose this is an array, right? And we are multiplying all the elements in by 2. If I was not using if I was doing the normal way, what I would do is I would take the first element in this array, multiply it by 2. So the first element will be location 0, right? And multiply it by 2, then store the result. Same I would go till the number of elements I have in the array, right? Instead of doing this, what I do is, what vectorization does is, it will take this unit as a whole and it will perform the same thing. But remember, this is going to happen one at a time. We don't do one at a time. What we do is we do something called as concurrency. So we do a0, a1, and like till an directly by 2. So basically, we are doing some sort of concurrency. We are splitting the data across different threads, right? So instead of having a single thread and operating it single by single, we are achieving some level of concurrency over here. So because what do you say, Python has that asynchronous behavior, right? We can achieve concurrency, and that is uh, how we achieve vectorization, right? So vectorization is parallelism in it basically it is in the background. Vectorization is nothing but doing parallel processing. Instead of operating on each single elements, we do multiple. We consider it as a single unit of work and we multiply it. But instead, we divide it on different cores. Right now, these days you have multiple cores. Yeah, computers have multiple cores, right? So that is what he means by you have batch computation, and then he says those are scalar operations. The scalar operations are like when you add two numbers, right? So you are not considering yeah, like you are taking two whole and directly adding it, right? For example, okay. Vectors were there in physics as well, right? In physics as well, or in other uh, so basically, whenever we are dealing with computer science, right? Uh, Especially when you're dealing with memory, right? So vectorized computation means working on a group of or holding multiple numbers to process together instead of working on single numbers. So that is nothing basically where we achieve parallelism, right? Basically, uh, in the background, we are achieving some sort of parallel programming, right? Now, uh, okay, now let's see. So the unit or the uh, uh, basic building block of an NumPy is basically we'll do an ND array, right? Now an ND is basically the basic unit of an NumPy is basically an ND array. So in NumPy we do not call it as a normal array. We say that is a ND array, right? Now an ND array is a generic multi-dimensional container for homogeneous data. That is, all of the elements must be of the same type. Every array has a shape, a tuple indicating the size of each dimension, and a D type and object is now. So now let's see ND arrays, right? So first is this is the basic building block. So as we said, if you want to perform more faster mathematical operations, what we would be doing is we would be storing data in an ND array instead of a tuple or a list, right? Okay. So now let's see how do we create an ND array. So So the first thing that we need to understand is creating an ND array. Okay. So let's see how we can. Oh, let's. What is that? Yeah. Let's have this thing. Okay. So now, uh, an ND is a generic multi-dimensional array for homogeneous data. That is, all of the elements must be of the same type. Every array has a shape. Some characteristic is so whenever we are storing in an ND array, data will be of the same type. Uh, every array has a shape, so every ND array will have a shape, a tuple indicating the size or the dimensions, and it will have a D type. This is indicating the data type of the array. So, like, what data type am I storing here? Okay, so first, let's do. So let's do. Let's create a ND array. So we do ND array here. There are multiple ways to create. Uh, they all refer to the same thing. It can be array. So ND array is more specifically or more technically. If you need to be correct, you are going to say it as an ND array. Now, whenever in future, you'll say it's an array or a NumPy array. It's all meaning the same thing. All are referring to the same thing. Suppose someone says it's an array, so it's indirectly what they are trying to do is they're trying to uh, say that it's a NumPy ND array. So first way to do is basically we use the array function, right? So we do np dot so let's do why the okay, let's get rid of this markdown. So that it was a markdown, right? So let's say np let's do dot and let's see the array function. So the array, this is the array definition. Define array. This is the D type. Then you have copy, boolean. You have lots of inbuilt methods here. So basically, what it is going to, can we? You know what? Let's open Python. I say that is going to be NumPy document is going to be more NumPy documentation. Yeah, let's okay, getting started. Okay, so let's first as we are going to do array. Okay, so okay, let's do NumPy dot array. NumPy. Okay. So what does it take? An array, any object exposing the array interface. An object is underscore array methods returns an array or any nested sequence. If object is scalar, a zero-dimensional array is returned. So what does it take? Oh, okay. Does it take? So first is basically it's going to take this object. Now what? Oh, what is this? Yeah, we can now. It will be a little bit easier to understand. So for okay, this has to be it's an object it has to be of type array. So this is the first parameter that it is going to take, and then uh, uh, now an object whose underscore array method returns an array or any nested sequence. So let's see this underscore this is a magic method, right? In Python you have certain methods which are special methods. uh, Array, an array, any object exposing the array interface. So let's see. So he's saying that this is an interface. uh, okay, so let's see which object exposes the array interface. So let's see, in Python everything is an object, so which object? So let's see which is doing that. So any object has that method, then the special method that can be passed in. Is that what is he trying to say? uh let's do this way. Now an array object exposing the array interface, an object whose underscore array methods returns an array or any. So it's saying a nested sequence or any. It can be bracket nested or normal sequence as well. So let's Okay, so this is what the definition is, right? So we can pass in any sequence. So let's pass in a Python sequence. So I'm going to pass in a tuple, and then let's say this is one method of, oh no, let's not do np. Okay, let's just run this cell. So even if you run this cell, then the output should come. Yeah, so now this is when you say this is, okay, let's say data 3 or something like that. Right click and send data. So now when I want to check, now if you want to check if it's a normal, uh yeah, you just do it, type, and then it should say that it's a n dimensional array, something like that. Yes, it says it's now a numpy.ndarray. So we have converted into that ndarray functionality, right? Okay, this is the first way. First way is you do np.array, right? Let's write down. So the first is using array. Now now this accepts any sequence, okay, and produces a new empire array containing the past data. We saw that. Now since data2 was a list of lists, okay, so you can, now this is a single list, right? What if I have inside this I have a list, like a nesting or something, right? mm, okay, let's say, so let's say this has two uh I would say just two columns. Let's say I have one more, so like I have 4, 5 and 6, right? And then let's say these are, so when I have a nested array, even this is an np dot array. If I check, the only thing is the dimension. So if I do data2 dot, now say I have different types of, so if I want to check the dimension, I do ndim, right? So if I just, so this is saying this is a dimension 2, right? Now since data2 was a list of lists, number has two dimension, which so there's two dimensions, right? So I have a oh, this is basically when you have a so this is like a proper I mean, so what if I have only one element? Will that works then? Let's close this. Now here, what is the dimension? Okay, so setting an array element with a sequence, the requested array, so it should be a homogeneous has an inhomogeneous shape after one dimension. Okay, so he's saying that this is it should be homogeneous in nature. It means the in the nesting also should be of proper dimensions, like it should be same. If you try to have a different one, then it might give you an array. Oh, now it's going to be settled. Okay, now there is one more thing. We can come this by inspecting the NDM. Okay, there is you can do something called as dot shape as well. Now what does shape, okay, shape, let's say go to definition. Now shape property, what does it do? Okay, shape. Okay, let's run it and see. That would be much more easier. Let's close this. This is going to give me the shape, right? So and then there is something called as d type, right? Basically indicating the type of data present in here. And there is a, this is in 64. That's okay. Now let's say what is the difference between endim versus shape. Now this is something that we need to understand. Okay, so we are going to see endim versus shape. The only catch using arrays they have to be homogeneous. By homogeneous you mean if even if I'm using a nested array, uh, nested sequence has to be homogeneous in nature. You can't have different thing. Okay, now uh, now basically endem is going to indicate the number of dimensions, and shape is going to indicate in the tuples or sizes of each dimension. For example, okay, here it's the same, right? Okay, let's add in the one side one more tuple. We say this is 9, 10, 11, 12, anything. A setting an array element with the sequence the requested arrays are inhomogeneous shape. Oh, this won't work. Let's, yeah. So let's have the data being printed, only the shape. Shape is going to be 3 comma 3, and then when I do, let's just write a print statement here so that it's getting covered. Oh, this is, so it hasn't printed this, looks like. And then here if I do data to dot inside window, oh, I do shape. So the end name is 2, and this is 3 so it's going to return a 3. It just returns a tuple. Okay, shape returns a tuple. Now basically it's going to say rows and columns in a 2D array. So how many rows and columns did I have? So here I'm having, it was having 3 rows 3 columns. Now what if I change this? What if I say, what if I add another 7? This is going to say 3 rows and 4 columns. The dimension is still 2. So number of dimensions basically, this is indicating that it's a 2D matrix, right? So number of how many braces that we have, that is going to decide the dimension, right? So this is a 2D matrix, so that is what is going to be given by 2. So endem is, so this gives us the dimension, like how many inner brackets do we have. Basically in other words you can say number of accesses. So what if inside this I have one more, so if you say this, say if I have 1, this is going to be 1, 2, or let's get rid of comma here. This is, so now it should say 3 axis, and then I have 1 row, 1 column, and this is going to be my z axis. So yeah, let's think about homogeneous arrays. Like, there is one caveat that here is it has to be homogeneous, right? Okay, so when I say homogeneous, uh, first is there are two properties that I'm talking about. One is basically they should be of the same type, data type should be same, and second when I say is shape also should be same. So you can change the, you cannot, so shape is basically in each nesting it is going to indicate the rows and columns, right? So rows and columns have to be the same number of rows and columns. If it's a nesting, if inside the nesting, if my initial one has only one row and one column, and in the second I have 2 rows and 3 columns, right? Then that won't work. It will give an array. Everything has to be same basically. Inconsistent becomes object, so we cannot do have inconsistencies over there. Okay, perfect. Now, in addition to NP, there are a number of other functions for creating various examples, zeros and ones. There is one more way. So if I want a, remember this is going to do homogeneous, right? So if I want to do NP dot, so I haven't talking about, yeah. So if I want to do zeros, you can go to the definition. Zeros. So what it does is it kind of creates a zero array, I guess. So arrange. In addition to, there are a number of other functions for creating a new arrays. An example: zeros and ones create arrays of zeros or ones respectively with given lengths. So you can whatever you pass in inside. So how much? So say if I say 10, then this if I say 20, it's going to be 20. So this is going to be 1, 2, 3, 4, 5, 6, 7. It's 0.0 is because how internally the variable. Now, caution is not safe to use an mp.empty. It will return an array of zeros. In some cases, it may release an initialized values as well. So it's not a better way. There is one more way. Array is array valued version built on Python, right? Because we are doing sequencing, right? We are passing in Python sequence. Now there is one more. Arrange is a array valued version. Arrange. So arrange is something like range, where you can specify how um, uh, you can create. How can you create? What if you need a um, say array of a specific type, right? So how to do that? So you can. There is one more way you can do. There is something called as np.arrange. So it's like a in Python you have. Although we are still in Python, it's a library in Python. So arrange. So basically you have stop. Uh, let's. Sometimes it gives the definition. So it's very easy. Okay, you have start, stop, step. So how much you can start? It's like the range version of creating an array, right? So for example, if I do say a range, so if I do a range of 10, so I'm going to create a 10 thing. So if I do just this thing, let's close this thing. So I've created 10 elements. There's 0 to 9 or 10 elements starting from 0 and going till then, because this is how range works, right? Okay, now data types, there are 4 specific data types. You have int 32, float 64. Now this is when we would be using optimization. Now whether our data should consist of 4 bytes or 6 bytes, this is for more sort of uh, memory efficiency, or when we would like to, if it's a other type of data, for example, although it does, even numbers can be strings, they can be ints as well. Now which utilizes the memory word. Sometimes when we import a data set, we might often convert a column which is a string data type to maybe an int type. Okay, so I guess, yeah, that is all for this session. I hope you guys liked it. That was just a brief intro to NumPy. We'll see a little bit mathematical operations as well, and then we'll go on from there. So yeah, that's all for this session. Hope you guys liked it. I'll see you guys in the next one. Till that time, take care. Bye bye.